Hi everybody, in this video we're going to be discussing a whole library of functions, as a matter of fact, a whole library of what I'm going to call parent functions, because this is sort of a lead-in to my next series of videos in which I'm going to be discussing transformations of functions. So given some very basic function, can we memorize its characteristics and then recognize how maybe messing with its rule or the equation we're given that's associated with the graph, how messing with that rule alters the original parent function, or the very simplest form of, say, that function, a linear function, a quadratic function, a cubic, a cube root, square root, how messing with those basic rules transforms the graph of the basic one into, say, a new graph. And having this understanding of what does what is really going to make our job a lot easier. Instead of having to memorize every single graph, there are infinitely many, what we can do is we can just memorize a simple core set of graphs and then just understand how changing their rule affects the graph. So anyways, let's go ahead and start over here on the left with linear. This is going to be really basic, but you'll notice here that I've written two of these over here. We've got this one here, f of x equals c, and f of x equals x. And I'm going to point one thing out here. We say that c here in this instance is representing a real number constant, as it has no variable. So it is important to point out, and of course we know that f of x is kind of like the y value, or the function value at this given x value. But for any function f of x equals c, it's important to note that you're always going to have a graph that is a horizontal line. It is a constant rate of change. So what we're going to do is hopefully, if you're kind of scribbling down these library functions, this is one graph you want to draw. But we say f of x equals c. Some important things to point out about this is that the domain. Okay, so we'll write the domain here. The domain actually is all real numbers. If we talk about what are the x values for which our y values defined, well, our graph spans from way out to the left at negative infinity all the way to the right to positive infinity. It's got infinitely long horizontal span. So there were no x values for which we had to lift up our pencil when we drew this graph. That is, it's everywhere defined. And in terms of range is really interesting. It's going to be a one set value, okay? And that set value is going to be at a height of c, okay? So you're going to notice here I used closed brackets as opposed to parentheses. All this means is that it includes c, okay? If I would have used, say, a bracket here, it would have meant up to and including infinity. But of course, we know infinity is not a set. It's not a set finite value. It's just a concept, okay? So we say the domain and range are these right here. Also important to note that it is horizontal, always a horizontal line. Okay, so real simple. That's about all we need to know about this first function here. Okay, so let's discuss this other one here. We say f of x equals x. This is the most basic linear function, and you might be saying to yourself, okay, well, shouldn't it look like y equals mx plus b? That's a good thought, starting with the fact that f of x is taking place of y, and our slope here is actually 1. Okay, and this has a y-intercept of 0. But we typically just say, hey, we should know it's f of x equals x. And I think it's important to note that we actually give this function a special name. We refer to it as the identity function. I'm notorious for putting bonus on quizzes and tests, and knowing something like that, it might get you some points sometime. But f of x equals x. Okay, so let's start with the graph of this function. It is an oblique line that had a y-intercept of 0. And it just proceeds up 1 and over 1 out from this. Of course, it has a slope of 1. And I bring up that up 1 over 1 thing from this origin here because we're going to be graphing a lot of other parent functions that kind of begin the same way. So we say this f of x equals x. So what are the things I want to know about this function? Well, first of all, I want to know the domain. The domain, from left to right, there are no x values that would ever get plugged into this function that shouldn't give us back a function value or a y value. So we say the domain is all real numbers, okay, all reals. All reals, the same thing as writing this interval notation here. We say x span from negative infinity out to positive infinity. In terms of the span on our y here, our range, we also say it's all reals. This graph continued or started way down at negative infinity with respect to y and proceeded all the way up to positive infinity without ever lifting its pencil. So we have domain and range, okay? It is important to note, just on a side note, that it forms a 45-degree angle with the positive x-axis there. Other things to note about this function is that it has a y-intercept of 0, 0. Of course, we've listed this, but always good to just kind of write out and put that on the graph. Okay. And so this identity function, you know, with the slope of 1, by the way, slope of 1, we could write that down as well, is a good one to have memorized. We mess with that one quite often. Okay, so going over here to the squaring function. The squaring function, this is your everyday parabola, but we say the most basic form of a parabola, okay? So here's what we want to know about this. In terms of graphing the squaring function, it has a y-intercept and an x-intercept at 0, 0. Okay, so 0, 0. I kind of say that's where it starts, and this is where we're going to call the vertex, of course. This is the vertex of the parabola. And it proceeds upward, but here's what I'm going to tell you. It goes up 1 and over 1 to the right. And this brings me to my next point here. We could test this for symmetry. Of course, if you imagine plugging in a negative x for this x here, you know it would just pop back to positive x because we're squaring it anyways. But this issue, or this illustrates y-axis symmetry. So before I go ahead and draw the other part of this graph, we're going to list this here. It has y-axis symmetry. Of course, this is something we're not surprised about. Okay, but we say, okay, so if it goes up 1 over 1 to the right, it also proceeds up 1 over 1 to the left. And we have our parabola here. So we say this is f of x equals x squared. And we call that the squaring function. In terms of domain, all real numbers, okay? All x values, when plugged into this function, will give us a valid and defined output, or a y value, okay? In terms of range, now this one's a little bit different here. I'm going to switch up colors. How about we switch over to red? That'll be a good contrast. But range, of course, remember, is kind of like our y span for this graph, you know. But the lowest y value, it starts way down here at 0 here. I'll try to highlight that. It starts down at a height of 0, and including 0, and proceeds on up forever and ever and ever and ever and ever and ever. So since it starts at 0 and includes 0, we say including 0, this bracket here. It starts at a y value of 0 in terms of a minimum, and then it heads up all the way up to positive infinity. It never stops proceeding upward. Okay. Other things important to know. We say increasing. Where is it increasing? Okay. And maybe, you know what, I'm going to put decreasing on here as well. It's probably better to start with decreasing in this instance because you notice we want to know what are the x values for which this is decreasing. You'll notice here that our graph is decreasing from left to right, but it's been decreasing all the way out from an x value of negative infinity all the way up to this x value right here. Okay. So our graph decreases from negative infinity all the way up to, and then not including 0. Okay? Because exactly at 0, we say it has a slope of 0 itself. So that's constant. Okay? But in terms of increasing, it starts at 0, and starts at this x value 0, and increases for the rest of the time. It just keeps going up and up and up and up for all x values to the right of 0. So we say out to positive infinity. Okay, and so that's just a few things that we're going to want to memorize about the linear and squaring functions.